So having the correct number of decimal places, having the correct number of digits in a reading from the lab is going to take us to our next topic, which is important when we start doing calculations with those numbers. So for example, one of the calculations you're going to do in the lab is measure the density, which is defined as the mass divided by the volume. So let's say that we measure the mass of a solution is 25.24 grams, and we divide that by the volume of the solution, and let's say it's 19.3 milliliters. So I'm assuming that we recorded the mass and the volume correctly, whether it was analog or digital device. We plug this in the calculator to come up with the density. The calculator, in normal notation, is going to give us a number like this with a lot of digits. And this has units of grams divided by milliliters. So now the question is, where do we round this? Is it 1 gram per milliliter, 1.3, 1.31? Do we record all of the digits? And the answer to that kind of question is the concept of significant figures. Or sig figs. So before we can answer the question of where to round this, first we need to learn the rules of significant figures. What digits have significance, which is another way of saying which digits have meaning and which ones do not. So the rule starts with anything that's not a zero is always significant. It's always meaningful. So the number 8.738, everything is non-zero, so this has 4 sig figs. The only thing that gives us trouble are zeros. If a zero is in between two non-zero digits, then it's also significant or meaningful. So the number 9.0009. It doesn't matter whether there's a decimal point or not. These zeros are in between the nines, so by rule number 2, these are also significant. So the nines are significant by rule number 1, and these zeros are significant. I'll underline the ones that are meaningful. So this shows 5 sig figs. It's when a zero is either at the left side or the right side of a number that gives us a little more trouble. A leading zero is a zero on the left-hand side of a number. So as an example, the number 0.08. This has 2 leading zeros. Leading zeros tell us about the size, the magnitude of the number, but they are not significant. So in the number 0.08, the only significant digit we have is the 8, so that's 1 sig fig. Trailing zeros are zeros on the right side of a number. And trailing zeros are significant if the number has a decimal point. So trailing zeros might be significant, they might not be significant. It depends on the decimal point. So for example, the number 83.000. Rule number 1 says the 8 and the 3 are always significant. These are trailing zeros on the right hand side, and the number does have a decimal point, so those zeros are also significant. This has 5 sig figs. if I had a number 470.0, again the 4 and the 7 are always significant. Now I have two zeros. These are still trailing zeros. It doesn't matter whether they come after the decimal point or before the decimal point. What matters is, does the number have a decimal point? And this one does, so those zeros are also significant. So this number 470.0 has 4 sig figs. If I just wrote 470, now 4 and the 7 are still significant, but this 0, there is no decimal point written down, so that 0, that trailing 0, is not significant. So this only has 2 sig figs. Technically, that's a trailing 0 before an implied decimal point. So technically, the book will tell you that those are ambiguous, whether they are significant or not. For this class, we're going to consider them to be not significant. So in other words, if I want this 0 to have meaning, I have to put a decimal point there. And now this trailing 0, because it's in a number that has a decimal point, gives me 3 sig figs. All 3 of those are meaningful. If I have the number 500, the implied decimal point would be right here, but because there's no decimal point written, only the 5 is significant. So that's 1 sig fig.